So in this video today, I'm going to talk about the distance formula and Pythagorean theorem, how they relate to one another, and the midpoint formula. So by the end of today, you're going to be able to find the distance between 2 points using a variety of methods and find the midpoint of a segment and an endpoint when given the midpoint and an endpoint. Okay? So first of all, the distance formula is derived from Pythagorean theorem. How do we know this? So when we look at over here, we have the length of A given here, and we have the length of B, right? So to find C in a right triangle, which is the hypotenuse, we would do A squared plus B squared. It equals C squared, and obviously to get C, we would take the square root of A squared plus B squared, okay? So the distance formula derives from the same thing. So once again, we're looking for the distance between A and B over here. So we're looking for this. This would be our hypotenuse, right? So that's what D is representing right here, okay, is the distance between A and B. And once again, when we start talking about this, we're looking at the X values and the Y values. So basically, if we look down here at this length here, we are subtracting our X value of X1 from X2, because that is what gives us the length from here to here, right? So whatever our X value here is and our X value is here, that's how we get the length. And then the same would be true of this right here, our vertical, right? So here again, we're looking at Y1 and we're looking at Y2, right? So once again, we're going to subtract them from each other to get the height. So that's why the distance formula is basically just a derivation or a derivative or a different way of looking at the distance formula and the Pythagorean theorem, sorry. Okay, so down here now, Pythagorean's theorem versus the distance formula. So we're actually going to do this now. So just find the distance between points A and B using both methods. Okay, so we're going to do this on a graph first. So we're going to plot point A, negative 1, 5, right here. So that's our A, and that's negative 1, 5. And then we're going to plot our point B over here at 3, 1. And what I'm going to do is I'm now going to draw some lines here to see where these meet. So I wanted to do that one in red, sorry. So we're going to do this one there. And that's 4 high, right? And then we're going to do, so we're basically drawing the legs of our right triangle. Y'all see that? So this is a right triangle, and then if we're trying to find AB, the length of AB, that would be this over here, right? So we're going to use Pythagorean's theorem to solve this. So what we're going to do is we're going to do our 4 squared plus our 4 squared, that's our A and B, right? So this would be equal to our A, and this would be equal to our B down here. And that's going to be equal to our C, which is over here, right? So that's going to be AB squared, right? So 4 squared plus 4 squared, so that's 16 plus 16. And that's still going to be equal to our AB squared, right? So 16 plus 16 is 32. That's still equal to our AB squared. Meant to put that squared up there. Okay, so how do we get rid of a square? We got to take the square root, right? So we're going to take the square root of both of these sides here, and that's going to give us now that AB is equal to the square root of 32. Well, hopefully you know that the square root of 32 is equal to the square root of 16 times the square root of 2. So AB, if we put it in simplest radical form, would be 4 square root of 2. That's the exact measure of AB. Now, if we want to approximate it, we would multiply those, okay? So when we multiply 4 times the square root of 2, we get 5.66. Now, this could also be true of taking the square root of 32. They would give you the same value. Now we're going to use the distance formula. And the distance formula is on your formula sheet. It's in the left-hand column, second item down, okay? So what we're going to do is we're going to use our distance formula to find the length of AB, okay? So to do that, I'm going to label this x1, y1, and this point B, x2, y2. So what we're going to do is we're going to put those in our distance formula, okay? So we're going to start out, and we're going to do our x2, which is our 3. We're going to subtract from it our negative 1. And then remember, we're going to square all that, right? Then we're going to add to that, again, our y2, which is 1. And we're going to subtract from it our 5, right? And again, we're going to square that, okay? So we're going to combine what's in our parentheses first, okay? So here we've got 3 minus a minus 1, so that's going to be 3 plus 1 squared. This over here, we can go ahead and simplify it. 1 minus 5 is minus 4, right? And we're going to square that as well. So then when we keep simplifying this is going to be 4 squared, and negative 4 squared is 16, right? So isn't this going to be 16 plus 16, and that's what we got before, so that's the square root of 32. We already know that if we simplify that, that's the square root of 16 times square root of 4, which is 4, times square root of 2. That's our exact answer. So that's AB, and then if we give an approximation of that by multiplying that, we still get 5.66. So now if we talk about the comparison of these two methods, what would you guys say? So I would say that for Pythagorean's theorem, you find the lengths, right? So let's just do this one in green because that's the way it is. Find lengths of sides, square them, and then take the square root of the result, or the sum, right? Square them and find the sum, and then take the square root of that. So we're going to just talk about that piece. Find the lengths of the sides and square them, because the rest of it's the same, isn't it? We start taking the square root. So let's talk about how they differ. So we find the lengths of the sides and square them. Well, the truth is that's exactly what we're doing when we use the distance formula too. But this time we're using the points. So we use the points to find the length of the sides, right? So that's the difference, guys, okay? So you just find the lengths of the sides by counting them with Pythagorean theorem, whereas you use the points to find the length of the sides when you are doing the distance formula. So this first one says find the length of each side and perimeter. So we're going to find the length of side AB. So to do that, I'm going to draw a right triangle right here. Y'all see that? So there's my right triangle, and there's AB. So we're going to find the length of these sides. So we're going to count 1, 2, 3, 4, 5 over here, and we're going to count 1, 2, 3, 4 up here, okay? So to find AB, we're going to do 5 squared plus 4 squared, and that's going to be equal AB squared, right? So that's going to be AB squared equals 25 plus 16. So AB squared is equal to 41. Now what do we have to do next? We have to take the square root of that, don't we? So we have to take the square root of AB squared, so we get AB is equal to the square root of 41, and if we compute that, that's approximately 6.4. Now we're going to find the length of BC over here, okay? So to do that, I'm going to go up again and over to create my right angle again. So again, BC is going to be my hypotenuse, right? So we're going to do BC squared. Now let's count this 1, 2, 3, 4, 5, and 1, 2. So this is going to be equal to 5 squared plus 2 squared. So BC squared is equal to 25 plus 4. So BC squared is equal to 29. Again, must take the square root of that. So BC is equal to the square root of 29, which is approximately 5.4. Okay, then our last length down here, AC, we can see it, right? AC right there, we can count that one. 1, 2, 3, 4, 5, 6. So AC is equal to 6. So now if we were to ask the perimeter, all we have to do is then add those 3 lengths together, right? So we're going to add, so if we say what is the perimeter of triangle ABC, that's going to be equal to our 6.4 plus our 5.4 plus our 6, right? So that's 5 and 6 is 11, plus 6 is 17.8, okay? All right, let's see if you guys can do this. You try over here on the right. You try 1. and find me the length of MN and PO. Those you can just count. Then you're going to use a right triangle to find the length of MP and NO. Do you notice that MP and NO are going to be the same length? Yes, good job. Okay, so go ahead and find those for me. Pause the video. Come back to me when you're done. Okay, so over here, I realize that this length right here is going to be these lengths right here of MP and NO are going to be the same, right? MP is equal to NO, right? So then I'm just going to 1, 2, 3, and 1. So this is 3 and 1. So I'm just going to find MP. MP is equal to, MP squared, I should say, 3 squared plus 1 squared. So MP squared is equal to 9 plus 1. MP squared is equal to 10. So once again, we got to take square root there, right, to get MP. So MP is equal to the square root of 10, which is approximately 3.2. Okay, which also means what? NO is equal to the square root of 10, which is approximately, again, 3.2. Okay, now we can actually count the other two sides, can't we? So up here we have MN, 1, 2, 3, 4. So MN equals 4. And then let's just do this bottom one in green. PO right here is 2. So PO equals 2. So to find the perimeter of MNOP, aren't we just going to add all this together? So we're going to do our 3.2 plus our 3.2 plus our 4 plus our... Did I put 0 there, y'all? What in the world? What was I saying? That's 2. I don't know what I was saying there. Plus 2. Okay, so we add all those together. 3.2 plus 3.2, so that would be 6.4 plus 4 is 10.4, so this would be 12.4. Okay? Okay, so example 2 says find the distance between A and B in the simplest radical form and then round to the nearest hundred. So this time we are going to solve this with the distance formula, okay? So we're going to call this one X. Actually, let's do some different colors here. So let's call this one X1, Y1, and this one X2, Y2. And we're going to plug those into the formula. Again, remember, this formula is on your formula sheet. So AB is equal to the square root of something squared plus something squared, right? So we're going to take Y2, which is our 4, and we're going to subtract from it a -1, okay? Then we're going to take our y2, which is -19, and we're going to subtract from it our 7, okay? So we're going to simplify what's in these parentheses. Now, you can take an extra step here, but I kind of like to, if I see two negatives next to each other, I just to make that a plus, okay? So that means for our next step down here, we're going to have 4 plus 1, which is 5 squared. And then for this, remember, if you have two negatives, it just makes a bigger negative, right? So this can be -26 squared. Now, keep in mind that when you do this in the calculator, you need to put parentheses around the -26, because if not, you're going to end up with a negative answer. And you all know that a negative times a negative is never a negative answer. It's always a positive answer, right? So now what we're going to do is this is going to be 25 plus 677. So that's equal to the square root of 701. That's the exact answer for AB, okay? That's equal to AB. And then if we want to give the approximate answer of that, then we go ahead and take that square root, and that would have been 26.48, okay? All right, example 3 says find the distance between the points -3, -6, and 1, -2. So once again, I'm going to do the same thing I did before. I'm going to name this one X1, Y1. And this one X2, Y2. Now you guys don't have to do this extra step, but I like to because it helps me keep things straight, okay? So on this one, again, we're just looking for the distance. We don't know what the points are. So we're going to put it underneath our radical again, and we're going to square whatever that is, plus we're going to square whatever that is, right? So we're going to subtract them, okay? So we're going to do 1 again, minus a -3. Oops, let's do this one in red. Maybe if I can get the red to choose, okay? and then that's going to be another parenthesis there, right? And then we've got -2 minus a -6, okay? So here you notice we got negative, 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 negative again. So we're going to go ahead and change this to plus. We're going to change this to plus. So then we can do our next step easier, right? So this is going to be 1 plus 3 is 4, so that's 4 squared, plus, and that's -2 plus 6, so that's going to be 4 squared again. Wow, this one looks a lot like one we did earlier, right? So this is 16 plus 16, that's equal to the square root of 32. That's equal to the square root of 16 times the square root of 2, which would be 4 square root of 2. That's our exact answer. And then if we go ahead and approximate that by taking that, it's 5.66. Okay, let's see if you guys can do this U-try right here. And you're finding the distance between KL, okay? Pause the video, come back to me when you're done. Okay, so all I'm doing here is basically setting up the problem again. I'm going to do x1, y1. I'm going to do x2, y2. So this is going to be 10 minus a minus 5. Okay, and then over here we're going to do another 10 minus, this time just a 5, right? So let's go ahead and simplify again. Minus minus means plus over here. So this is going to be the square root of 15 squared plus 10 minus 5 is 5, 5 squared. So that's going to be the square root of 225 plus 25. So that's the square root of 250, and hopefully all of y'all can see that 25 would be a factor of that. So this would be equal to the square root of 25 times square root of 10, which is equal to 5 square root of 10. That would be our exact answer. And then when we approximate that answer by multiplying 5 times the square root of 10, that would be 15.81. So that's the distance formula, okay? Now, next we're going to go over the midpoint theorem and the midpoint formula, okay? So the midpoint of a line segment is the point that divides the segment into two congruent points. So if we have two endpoints here, right, and we want to split it into two congruent parts, where that would be the same length as that, then we need to find the point that divides it into two equal points, which is why when we add the values of x together and divide by 2 and add the values of y together and divide by 2, that's going to give us our midpoint, okay? So on this one, we are going to, again, I'm going to label x1, y1, and x2, y2, okay? So here is pretty easy because all we're doing is -2 plus 4, and we're going to divide that by 2. That's going to be our midpoint of x, okay? So when we do that, -2 plus 4 is 2 over 2, so that's equal to 1, right? So that's going to be our midpoint, our x midpoint. Then we're going to find our y midpoint, okay? To do that, we're going to, again, add those 2 points together. So we're going to add our 1 plus our 10, and we're going to divide that by 2. So that's going to be 11 divided by 2, which is 5.5. So that's our y midpoint, right? So now our midpoint is 1, 5.5 when we put it back as a coordinate point xy. All right, let's see if you guys can do this here. So again, add the 2 points together, divide by 2. Okay, so here we go again. x1, y1, x2, y2, right? So we're going to add 2 plus 6, divide that by 2. That's going to be our x midpoint, right? So that's going to be what? 8 divided by 2, which is equal to 4. Then we're going to do our y midpoint. Here again, we're doing 2 plus 5, and going to divide that by 2. So that's going to be 7 divided by 2, so that's going to be 3.5. So our midpoint is going to be 4, 3.5. All right, our next one says a line segment has one endpoint and a midpoint. So you guys got to really read these types of questions, okay? So when it says something like this, let's back this up so it doesn't look so confusing. So a line segment has one endpoint at 5, -8, and a midpoint of -7, -4. Locate the second endpoint. So this is one of those things where if you don't read, you're going to get the wrong answer, okay? So this is an endpoint, so this is our x1, y1, but this now is our midpoint. So this is xm, ym, and that's why I was using that notation before. So now we have that our midpoint is -7, and that's equal to our x1, which is 5, plus whatever our x2 was divided by 2, right? So how do we get rid of that 2? We multiply both sides by 2. So that's going to give us -14 is equal to 5 plus x, because these two cancel each other out. So we're going to then subtract 5 from both sides. So subtract 5 here, subtract 5 here. So that means our x value is going to be -19. So that's one of our endpoints. That's really x2, right? You could have called this x2 if that helps you, okay? So now let's do our other one. So this is now going to be our y value, right? So -4 is equal to, again, we've got our -8 plus our y2. And we're going to divide all that by 2, right? So once again, we're going to multiply both sides by 2 here. So that's going to be -8 is equal to, these cancel each other out, so -8 plus y squared. So how do we get rid of a -8? Don't we add 8? We're going to add 8 to both sides, so that means 0 is equal to y, 2, right? So this is then our other endpoint. Our other endpoint is going to be -19, 0, okay? So how can we check this? We can plug it back in, okay? So if we add together 5 minus 19 divided by 2, that's going to be 14 divided by 2, which, sorry, -14 divided by 2, which is -7. Right there, that's right. And then let's do the same thing with our other value. So we're going to take our -8 plus 0 divided by 2. That's going to be -8 divided by 2. That's -4. That also checks out, okay? So I like these types of problems because we can check the answers, okay? So all right, let's go ahead and see if you guys can do this. You try, noting again that you have an endpoint and a midpoint. So once again, if this is me, I'm going to say this is my x1, y1, and this is my xm, ym. Okay, go ahead and do this. Come back to me when you're done. So here again, we're going to do 5 is equal to our -2. Let's do this in the color we did. -2 plus x2 divided by 2. Multiply both sides by the 2. So that's 10 is equal to, these cross out, -2 plus x2. Add the 2 to both sides, so we get 12 equals x2. Now let's go on and do our other one. So here again, we're going to say our y value, -2, is equal to our 4 plus our y2 divided by 2. How do we get rid of that 2? We multiply both sides by 2 again. So this is -4 is equal to 4 plus y2. So we're going to have to subtract 4 from both sides, right? That means -8 is equal to our y2. So that tells us that our point is 12, -8. Again, can we check this? Absolutely. So let's go ahead and do that. So that means we're going to go -2 plus 12 divided by 2. That's going to be 10 divided by 2, which is 5. That one checks out, right? And then we're going to do -8 plus 4 divided by 2. That's -4 divided by 2, which is -2. That one also checks out. Okay? All right, the last one here says show mathematically that 5.5 is the midpoint of the line segment with the endpoints -2, 1, and 4, 10. use the distance formula. Okay, so if we're going to do this with the distance formula, then what I'm going to do is I'm going to make, let's go ahead and just do this. Let's make this one x1, y1, and we're going to make this one x2, y2, okay? Because what we want to see here is, are they the same length, the same distance between them, okay? So when we do this, we're going to do our distance here, and that's going to be equal to the square root of 1 minus a minus 2 squared plus, so I'm doing this, y'all, right here, those two, okay? And then I'm going to do 5.5 minus 1 and square that as well. So when I did that, again, remember, if I do a minus, that's a plus. So this is going to be the square root of 3 squared plus, that's going to be 4.5 squared. That's going to be 9 plus 20.25. So that's going to be 29, square root of 29.25. Now, all we need to see here is, do we get the same value when we do it the other way? Okay, that's what we really need to see. So now this time, I'm going to call this one x2, y2. No, sorry, did that wrong. x1, y1. x1, y1. So now we want to see, are these the same distance, okay? So here again, I'm going to do this squared plus that squared, whatever that is. Okay, so we're going to do x2, which is our 1, minus 4, right? Let's do our 4 like we did up there. See the 4 right here? Okay. And then over here, we're going to do 5.5. And we're going to subtract from it minus 10. So 1 minus 4 is a negative 3. That's squared. And this is going to be plus a negative 4.5 squared. Well, remember, anytime you multiply a negative times a negative, you get a positive. So it looks to me like we're getting the same numbers here, right? Yep, and that's the square root of 29.25 again. And because these are equal, then yes, we just proved that that is the midpoint, because the distance from both endpoints to the midpoint are the same.